Good morning, good afternoon. A warm welcome to all our attendees today from across the globe. Thank you for joining us for this webinar on Big Data Analytics Platform Beyond Traditional Enterprise Data Warehouse. My name is Lisa Glenn, your host and presenter for today's session. Joining me as the expert speaker is Nishant Garg, the Big Data expert from the Impetus Labs. Nishant is among the significant contributors to our Big Data projects and really has established an expertise in this domain. Now, in the next 40-minute session, we're going to go ahead and discuss the need of building a big data analytics platform for better business insights. So let's have a look at what today's session has in store for us. At the end of this webinar, you will be able to understand the growing need for designing an enterprise data warehouse to support the business analytics derived from the big data. We'll also share the options and challenges of building a successful EDW architecture to meet the new big data business requirements. Now, this may include extreme integration with semi-structured and unstructured data sources, which may be very large in size, say terabytes or petabytes. It can also be the streaming data accessed through Hadoop, as well as massively parallel databases, and then structuring the data to support advanced analytics. So let's go ahead and get started. Now, one of the very basic goals that every business owner and stakeholder has is how to maximize the profits and reduce expenditures. Business owners need to find the right target users, figure out all the distribution channels, successfully sell their offerings, as well as keep all the stakeholders happy. Moreover, every time the business owners come up with a new product or campaign, or wishes to evaluate their existing business performance, they will have certain questions in their mind. In fact, you can see some of these questions on your screen now. They include, what kind of products are my customers interested in which area should we open our new store next year, and what is the most effective distribution channel? Your big data has valuable insights that can really help you address all these pertinent questions. But for now, I'll share with you more about the enterprise data warehouses. Traditionally, businesses have used enterprise data warehouse, or EDW, solutions for providing analytics and gaining deeper insights to address their business requirements and expansion plans. EDW plays a pivotal role in enterprise IT strategy. A comprehensive EDW strategy enables disciplined data integration within a large enterprise, generates output, and facilitates effective representations of all business processes. Let's take a look at how the traditional EDW works. Now, on the left side of your screen, you can see the traditional data sources, such as operational DB, old archive data, flat XML files, or OOP systems. The data is extracted, cleaned, and transformed into the desired format, and then loaded into the data warehouse storage system. Now, this data can be further divided into marts. Once the data is available in the central EDW, query or reporting tools are used for analytics. However, for deeper or path-based analysis, data mining tools are used. So, having discussed EDW, I'll now pose a question to you. Are these data warehouses ready to deal with the big data? Let's find out. So first, what is big data? We use this term for the data sets which can't be managed or processed by the traditionally used software tools within an agreed elapsed time. The big data size is constantly increasing, ranging from a few terabytes to many petabytes. However, it's expected to reach about 35 zettabytes by the year 2020. I now want to take this opportunity to ask you all a question that you can actually share your input. Where does the traditional enterprise data warehouse fall short of the big data expectations? Now, your options are data size, storing and managing the big data, gaining insights from this data, and costs involved in dealing with the big data. And you can go ahead and answer this question on the right side of your screen, and you have a total of 30 seconds to respond. Okay, it looks like we have the results, and as for a majority of our audience, it looks like the traditional EDWs are failing in gaining meaningful insights from the big data. Nishant, would you like to comment on this?
Sure, thanks Lisa, and a big hello to the audience. Thank you for joining us today. I mostly agree with you all on the poll results. However, I would also like to point out that the traditional EDW are just not meant to handle terabytes and petabytes of data. Most of these systems were designed in 1990s using the database technologies. At that time, the volume that we were generating today in petabytes and terabytes were just unimaginable. Furthermore, due to its nature and sheer size, the big data cannot be analyzed with SQL or similar technologies. I would also share that the database schema does not allow complex unstructured format to be defined and managed in these data warehouses.
Great, thanks Nishant. So as Nishant pointed out, our existing EDW environments, which were designed decades ago, really lack the ability to capture and process the new forms of data within reasonable processing time. Moreover, these traditional EDWs have limited capabilities in analyzing the user behavioral data. Now, the cost is another important factor. Currently, we might be spending hundreds of thousands of dollars per terabyte per year for producing and replacing data in our existing environment, which is huge. And additionally, these models tend to require specialized hardware, which in turn results in big dollars per terabyte cost, making the large-scale deployment expensive. And it's also really hard to predict the infrastructure workload for managing this big data. Our next slide is going to help us understand these limitations a little bit better. Traditionally, the enterprise data warehouses focused only on the transactional or archive data. However, in the last few years, the need to capture additional data for deeper insights has come up. This includes real-time data, which may be the low-latency operational data or the customer behavior data, which captures the sub-transactional processes. Social media also gives valuable information on product preferences and user sentiments. This is extremely useful for generating business intelligence from the large unstructured data generated from the web applications. A big data analytics platform can address the various limitations of traditional EDW and will help extract meaningful and actionable insights from this ever-increasing pile of digital data. As you can see from this diagram, we've also added these additional data sources. The traditional data sources are now producing higher volumes of data as compared to earlier. These devices or sensors can also serve as additional data sources. Another difference is that in place of ETL, the big data warehouses need ELTL, which is extract, load, transform, load. The new system needs a staging area where data is uploaded before the cleansing and transformations operations. The traditional relational database solutions are just not suitable for a majority of data sets. The data is too unstructured and too voluminous for a traditional RDBMS to handle. Moreover, the cost involved to handle these new data sets by using traditional technologies is also very high. Now, to manage this big data trend, a new breed of big data open source and proprietary technologies has emerged for leveraging commodity hardware. A big data analytics platform helps capture and analyze these new data sets. The ideal big data analytics platform should match up to these key characteristics that are listed on your screen now. First, these systems should have the ability to scale easily to support large data, which will be terabytes or petabytes. The systems should also ideally be distributed across geographically unaware processors. They should enable quick response to a highly complex queries as well as support a wide variety of data types. Now, add to this mix the ability to incorporate machine learning, providing recommendations, and executing analytics on real-time incoming data, such as logs, as well as providing domain-specific canned reports. It should also be able to handle data from heterogeneous data sources, while providing a high rate for loading and analysis, as well as the ability to handle failover. This, ladies and gentlemen, are the essential features of an ideal big data analytics platform. Now, in our coming slides, we will discuss building big data analytics platform with you. But first, let's go ahead and understand more about the various available options. We should first understand that for building a big data analytics platform, any single vendor technology may not be sufficient. The platform should have some certain capabilities to address your set of requirements. Furthermore, the complexity of a BI solution is usually very high and uses different components to build a single integrated platform. Now, there are two different approaches that are being used to address big data analytics. The first one is using massive parallel processing and columnar database. This solution can really help address scaling, distribution, load management, response time, and failover management. Additionally, it may also have some domain-specific capabilities to provide a ready-made solution. The second option is using MapReduce implementations. This framework was initially used by Google to perform web searches and is now easily available as open-source Apache project called Hadoop. So, if you have an option to choose between open-source solutions and commercial options, or if you'd rather, build a hybrid of these two, which has a mix of different capabilities to handle the big data platform. Let's go ahead and discuss these options in a little more detail. The commercial tools have strong analytical proficiencies as well as sophisticated reporting and OLAP cube capabilities. We also have a large number of vendors who offer solutions for main components of EDW, which ETL, query tools, and BI. Some of the commercial options for MPP are Greenplum and Teradata. Informatica is an example of ETL, and for BI and analytics, some commercial solutions are Pentaho, Business Objects, and MicroStrategy. We can build a big data warehouse solution using these commercial products together. The next option is open source. Every organization, big or small, is nowadays cutting down on their IT expenditure. However, business analytics is still one of the major business drivers for these companies. Now, if we try to scale these commercial solutions to really huge volumes and deeper BI, it may result in exorbitant licensing costs for you. And this is clearly not a viable option. And therefore, we have an option to choose from the numerous open source implementations that are available. Cost, extensibility, integration are some of the main features that you get with any open source solution. And the good news is that the community is continuously making efforts to develop the features and add new functionalities to these solutions. You can actually see some of the popular options on your screen. Some of the open source solutions stack in the analytics world are JasperSoft, Pentaho Reporting, and some ETL tools are Clover ETL and Talend. Pentaho also provides a commercial extension of its solution. Apache, Hadoop, and Cassandra provide implementations to MapReduce framework. These products solve huge data storage issues as well as provide ETL and analytics support. Now, our next option is going for a hybrid solution. Here, we can use open source solutions for ETL or the BI and a commercial solution for analytics or vice versa. Say, Hadoop and MPP solutions can work together as ETL pipes along with a commercial analytics tool. Or we may choose to use MPP and columnar databases along with MapReduce to provide another perfect hybrid solution. In our next slide, we'd like to share the lessons that we learned while we were building an open source based enterprise data warehouse solution for big data. We learned from our experience that when you have larger volumes of data to be analyzed, you're better off using open source solutions. Now, we think Hadoop is one of the best available open source solutions that can help you in handling your big data in a cost-effective manner. Now, it also makes sense to use parallel processing for other fast mechanisms while trying to import from open source system or export to a destination system. Another thing that we want to share with you is that real-time is a myth in big data. You need to carefully design your warehouse system so that the real-time data can be limited by size or by time. Now, it's possible to reuse some of the existing EDW investments in building a big data platform, and we'll discuss this a little bit more in detail later. But for now, I'd like to share with you that based on our project experiences, we've built a big data analytics platform for our clients that can help leapfrog big data analytics initiatives. This platform is called iLadap, which is short for Impetus Large Data Analytics Platform. And I'd like to ask Nishant, our expert speaker for today's session, to tell you a little bit more about this. Nishant?
Thanks, Lisa. The diagram that you now see on your screen shows high-level view of large data analytics platform developed by Impetus. The core iLadap platform is built using SOA and incorporates all the key characteristics of ideal big data analytics platform that Lisa shared with you some time ago. iLadap is designed to deliver intelligence and operates on huge data sets collected from the numerous data sources in multiple data formats. It is powered by Hadoop and therefore can linearly scale up to thousands of nodes using commodity hardware. This spells a significant cost advantage in long term. iLadap also comes with pre-set of pre-trained reports and customized reports. We know that it is important for business to track down and take advantages of an opportunity as it happens. Our platform enables you to react to the events as they happen. iLadap is also capable of collecting data from the range of disparate sources. This unstructured data can be transformed and utilized for strategic business decisions. Furthermore, you can also deploy this solution on premises as well as in cloud-supported deployment setup. iLadap can be seamlessly integrated with your current platform without making any major changes. As shared with you, the core iLadap platform is built using open source technologies, where the components can be replaced with other commercial technologies as per the requirement. We will now discuss the best possible approaches to selecting the right tools to address your big data problems. We used OZ-based Visual Designer to create the ETL workflows. There are other tools such as Scoop, which may be used to import the data from the traditional databases to the NoSQL databases. For integration with traditional ETL, Informatica, Talent, Clover plugins are also available. We would need NoSQL databases, which can store such large volumes of data. Their primary features are being non-relational, distributed, open source, and horizontally scalable. Some other characteristics may also apply, such as schema-free, easy application support, simple API, and eventually consistent support for huge data amount. The NoSQL database categories includes column family-based data stores such as HBase, Cassandra. These databases are best suited for applications where you write more than you read. Other category of NoSQL document-based data stores such as CouchDB and MongoDB are appropriate when you need dynamic queries as well as when you prefer to define indexes. Lastly, the key value tuple store such as Membase, Redis, etc. are suitable for rapidly changing data. Foreseeable data sizes should be filled mostly in memory. For example, stock prices, analytics, real-time data collection, real-time communication. There are many options available in the market that allows integration of MPPs such as Greenplum with Hadoop. This is worth considering if you have large amount of data, even after applying summarization over it. using Hadoop for cleaning and transforming the data into structured form allows you to load the data in any of the available options of MPP databases. While the data is being uploaded, you may write your own function calls to perform the data level analytics. MapReduce programming paradigm can be used for performing analysis on large-scale data. We can use Apache Hadoop for large-scale computations and data processing on a network commodity hardware. Pick and Hive can be used to remove the complications with Hadoop and give the programmers an easy interface to interact with Hadoop. Intellicus, Pentaho, MicroStrategy, etc. can be used for BI reporting, and Apache Mahout can be used to generate machine learning. Solr-based search engines can also be used to provide real-time analytics, and for rule engine and complex event processing, JBoss rules or rule fusion can be integrated. For application integration and development, open source options such as Kundra and CastUI can be used. So in all, we can simply say using all these tools makes sense when you are re-architecting your application for big data architecture.
Great, thanks, Nishant. That was really helpful. We're now going to talk about reusing the existing investments made in the traditional data warehousing to build a big data analytics platform. We believe that it's possible to reuse most of the hardware since the big data solutions can run on commodity-grade hardware. So an existing RDBMS-based infrastructure can be reutilized. The existing code logic and algorithms can also be used after minor modifications to enable it to run in a stateless architectural environment. Now, in this scenario, tools like MATLAB can be integrated with Hadoop-like technologies. Another way of utilizing the data warehouse investments is by extending or enhancing its capacity through plugging it together with a big data warehouse solution. For example, Hadoop is a cost-effective option for storing archival data, performing deeper analytics, and providing summarized reporting data to existing data warehouses. This strategy can also help in reusing the reporting tools. Now, similarly, the ETL tools can be modified to use big data warehouse as sinks. Tools like Talend or Informatica provide connectors for using Hadoop and commercial MPPs as data sinks. The development and testing strategy can also be reused. And most of the new big data warehouse solutions support SQL or Java or scripting languages and allow reusing existing development and testing investments. I now would like to share with you some real-world examples where we use the big data analytics platform to address some mission-critical business problems. Recently, we here at Impetus engaged with a client who is the leader in the Internet and multimedia services in Europe. Our engagement with the client started with understanding their system and to develop a new reporting system for their leading web portal. Now, there were some basic concerns that the client wanted to address, such as performance, horizontal and vertical scalability, periodic data consolidation and filtering, handling large volumes of data, and providing near real-time analysis on the subset of data. Now, what made this project all the more interesting was that the web data traffic on the portal was immense. The large number of page views had crossed a whopping 3 billion, and the number of user logins to 70 million per month. They were also expecting a growth of 300 gigabytes in the data set. So based on a thorough analysis of the client requirements, we proposed a solution that was cloud compatible and was really able to handle the client's big data needs. Our solution was comprised of some popular open source technologies like Flume, HBase, Hive, along with our custom analytics platform. Now, in the system, the logs were collected using Flume. This data was stored in an unstructured format into HDFS using HBase or directly over HDFS. For the analytics part, the data model was presented in the form of a Hive schema. The application also had a component whose main responsibility was to initiate or trigger data aggregation process over the raw or fact data to the aggregated or archived data. Now, as the next step, we built a component which was mainly responsible for creating reports over this collected data. This component was interacting with the data storage system via the JDBC bridge, for example, Hive, to extract the required data for reporting and analytics. The components were also responsible to produce reports in the desired format like PDF, CSV, etc. Next, we built a component for near real-time reporting. Since this report was to be generated over a limited data set, it was easily achieved via Hive-based analytics. Now, this solution was able to generate results in less than 15 minutes, which was quite acceptable to our clients. The complete solution was based on the Impetus Large Data Analytics Platform, or iLadap, and was deployed on the cloud. Since the application we developed was virtualized, it didn't take much effort importing from one cloud provider to another. I'd like to share with you actually another case study for you now. And in this case, the client was one of the key players in the telecom industry. Our client's major concern in this case was running analytics over their CDR data. The client also wanted analytical reporting solutions for customer churn analysis. Now, we first needed to understand the client's CDR data format and converted the same so that it can be displayed in the form of a canned report. We also proposed a reporting-based big data solution that has components for CDR data conversion and generating analytics for customers. We chose the Intelligence Reporting Suite to provide user-friendly reports and deployed it over the cloud. Hive and MR jobs were used to derive the customer churn analysis. Now, some of the churn and analytics our solution provided were switching and termination trends, payment and recharging patterns, subscribers' life cycle, and profiling, etc. And I'd like to share with you actually another example for you. And in this case, the client is among the leading online retailer and offers thousands of products. This client desired a cross-product customer analysis across multiple business units and product lines. Now, these product lines had their own databases and were not sharing customer details with each other. We were required to capture the customer activity at the session level and correlate multiple sessions over time for each individual user. Additionally, they were also looking for product recommendations for their customers. We developed an understanding of the client's product data and then set up a relationship between the customer entities that existed in different product databases. Based on our understanding, we proposed an iLadap-based clickstream solution and Apache Mahout for running machine learning to generate forecasting. Hive was used to drive analytics for cross-product customer analysis. Now, in this particular case, Apache Mahout and Hive were also part of the iLadap platform. I want to let you know that for all these projects, we use the ready-to-use components of the Impetus iLadap platform. It really helped us provide fast and scalable solutions to our clients. There was minimal effort required for installation and setup of the proven technology stack, such as Hadoop, Hive, HBase, etc. I'd like to now recap some of the key points that we've covered in today's session. The traditional enterprise data warehouses just do not have the ability to keep up with the growing demands of the big data. The immediate need is to effectively strategize and build a big data analytics platform to manage, store, and derive insights from this digital data. We'd also like to repeat that any single vendor technology may not be sufficient. We in fact recommend going for a hybrid of commercial and open source options in building a big data analytics platform for its flexible cost model. Now, when you have larger volumes of data to be analyzed, we suggest that you go with open source solutions, Hadoop really being the best option. We believe that the success of your big data platform entirely depends on the tools that you choose. So use your discretion and really select the most appropriate tools from the available options. You may reuse existing EDW investments for your big data analytics platform, and as discussed earlier, real-time analytics is usually not possible with big data. Now, it looks like we've started to receive some questions from the audience, and I'd like to remind you that you can go ahead and use the chat panel on the right to ask your questions. But before I take up those audience queries, I'd like to introduce Impetus Technologies. Impetus is a leading technology and R&D services provider with a strong focus and established thought leadership in the area of large data analytics and high-performance computing. We've built top-tier expertise and offer consulting and professional services in technologies like Hadoop, numerous NoSQL DBs including Cassandra, MongoDB, Membase, and a range of commercial MPP products and ETL BI analytics tools. With ongoing investments in research and application of emerging technology areas, innovative business models, and an agile approach, we partner with our client base comprising large-scale ISVs and technology innovators to deliver cutting-edge software products. Our expertise spans the domains of large data management, cloud computing, data analytics, mobile, SaaS, testing, social media, web technologies, performance engineering, open source, among others. Now, it looks like we've received our first question for Nishant, and someone is asking, can iLadap help in reducing the time to market for a big data solution? Nishant, what do you think?
Certainly. iLadap is an integrated platform offering out-of-box support for advanced ETL, analytics, and machine learning using proven open source products. We have seen saving anywhere from 20 to 70% effort and time in setting up big data solutions. It also has plug-in connector-based support for integrating commercial tools such as reusing the existing investment. For example, you might be able to reuse analytical reporting tools. Plugging it with iLadap platform, thus reusing your most of the reports.
Okay, great. That was a great question. And it looks like somebody else would like to know, can you suggest some examples of hybrid EDW solutions? Nishant?
Yeah, we have seen that most of the commercial MPP-based EDW solutions are generally very expensive to scale. One of our recommendations to customers already using expensive MPP solutions such as Teradata, Netsa, Oracle Exadata, Vertica, Greenplum, etc. is to integrate it with Hadoop-based solutions so as to reduce the overall analytics cost. Let's take an example. Say a MPP solution cost $1 million for analytics on 6 months worth of 500 terabyte data. Scaling it for analytics on 2 to 5 years data volumes can be exceedingly high due to the expensive licensing model. We would effectively continue using the MPP solutions for low latency 6 months data analytics, while Hadoop can be used for running analytics on the entire set of data. So as a thumb rule, if low latency is not very high requirement, Hadoop-based ETL as well as analytics can be at 30 to 90% more cost effective than MPP solutions.
Okay, another great question. It looks here we've got another question for you, and this one asks, I'm looking for a big data solution for customer acquisition and segmentation. Can iLadap be a possible solution for me? What do you think?
Sure. iLadap can be easily customized to build customized big data solutions. In fact, it is a platform for quickly building big data solutions. In advanced integration with machine learning and NLP engines like Mauer, Hadoop-based ETL capabilities and analytical support using MR, Hive, Pig scripts, and rich connector ecosystems allow to develop a solution really fast.
Okay, great answer. It looks like we've got another question that came in, and this one asks, what are the technologies you deploy to get real-time analytics? Prashant?
Well, there are many Hadoop variants for real-time support, such as Hadoop streaming. Also, Yahoo is working on a framework called S4, but there is still scope of requirement. Our iLadap platform supports Lucene and Solr-based indexing solutions over limited set of data.
Okay, great. It looks like we have one more question coming in, and let's see what that is. Oh, no more questions? Okay. Unfortunately, it looks like that might be all the time that we have to answer the questions live, but we will be addressing all those remaining questions that we received through an email later after this. Oh wait, it looks like we might have time for one more. Okay, one more question. And this one asks, okay, we have received some more, and those questions include, what are you seeing with Oracle, Exadata, and Exalogic? And are they having any traction? And what is Microsoft doing about this space? Another question asks, some cloud providers are using BI tools in a virtual machines, and do you have any thoughts on this? And unfortunately, because we've run out of time, we'll go ahead and answer those questions over email to you. And again, I just would like to thank all of our audience for their time and their great questions. We really hope that this discussion was a learning experience for everybody and will add value to your big data initiatives. Now, if you have any questions, please email us at inquiry@impetus.com, or you can visit our website, bigdata.impetus.com. Once again, thank you so much for joining us in today's session. Goodbye.